Hello everybody, thank you for the invitation. So my name is Shira Berg. I'm the founder of Symbiosis, and in profession I'm a veterinarian doctor. And actually everything started from my frustration to treat dogs with mitral regurgitation. But today I will talk about Cinderella's glass slipper. It is beautiful and shiny. It assures living happily ever after. But the only downside is that it's reshaped and pre-sized, and it fits Cinderella perfectly and gave her a happy ending. But imagine the disappointment of all the other women in the kingdom. They tried on the shoe and it didn't fit. So with TMVR today, this is the problem. These annular shapes are the fairy tale. But eventually, in reality, this is sometimes what we get, with up to 80% of patients remaining ineligible for current solutions. So with the principle of form follows function, as said in American architecture in 1869, for a dynamic anatomy, we need a dynamic device. And for that reason, we have developed ValSync, a dynamic adjustable device. It is inflatable, composed out of two highly compliant balloons and an adjustable anchoring system that is supported and controlled by a simple inflation of the ventricular balloon. The compliance of the balloons allows for a wide range of annular sizes, starting from 28 millimeters and can go up to 62. The barbs and the sandwich effect of two balloons ensure stability and prevent migration. So this is a transfemoral transeptal approach with a split capsule, primarily exposing and inflating the atrial balloon for atraumatic supraannular positioning. The second step would be to expose the subvalvular apparatus, ventricular balloon, and anchor with adjustable anchors. The high compliance of the balloon allows to adjust to various shapes and sizes of the mitral valve, as you can see here. This is one of our preclinical cases in a swine model in a transapical approach. As you can see, it is highly echo-visible. You can see the atrial balloon, and during this step, the animal remains completely hemodynamically stable, followed by ventricular balloon inflation. At this point, we are done with the procedure. It is a fully functional valve, and the procedure took only 25 minutes. But the coolest part is to be able to assess and see PVL and treat it in real time. As you can see on the left side of the screen, we see a massive PVL, and after additional inflation adjustment, there is no PVL anymore. In addition to that, the adjustable anchoring system with the ventricular balloon inflation or deflation eliminates LVOT obstruction if needed. This is the final position of the valve. We have also implanted the implant in the tricuspid position without any conduction disturbances, and also successfully treated PVLs during the procedure. Due to the conformable characteristics of the balloon and basically with the robust anchoring of the balloon, of the ventricular balloon and the barbs, we're able to actually perform a very stable and optimally fitted implantation of the device in a highly friable and variable tissue, such as in mitral annular calcification patients. So currently we're in chronic animal experiments, and we expect to reach first in human by the end of 2026. I'm very grateful and thankful to have this team bringing the idea into life and eventually giving a glass slipper for everyone.
Shira, great job.
Yeah.
Oh, sorry. Are you done?
Really good job.
Almost. So to conclude, it allows for a rapid valve deployment, important to say in transcatheter approach, but also as a docking system for surgical valves in a minimally invasive manner. It is adjustable in real time to allow modification of LVOT obstruction and PVL prevention, leading to potentially higher eligibility criteria, reaching more patients such as MAC and challenging FMR patients. Hopefully accessing more physicians, since we're talking about a very simple, intuitive device for a complex disease. Thank you.
Shira, that was great. Let's call up Jonathan and Frederic. One question, Shira, is this for humans or
Yes.
animals?
humans.
Because I would do anything for my dog, Mr. Remington.
Me too.
Okay.
By the way,
We have two markets.
we're seeing percutaneous mitral valve therapies for King, whatever it is. What's that fancy dog that everyone pays a lot of money for?
Oh,
Cavaliers.
Cavaliers.
Yeah. So, we need you on both sides.
On it.
Great, well, sure, that was very impressive. Interesting technology. I think it's maybe a little bit aggressive to call the transcatheter mitral space a graveyard, but I think it's definitely a slow-moving train. There's been a lot of products out there that really have not worked out so far, or still just progressively working on them. And I think that might make people a little hesitant to invest in something like this, but I would say that this is something that has a unique play in the space. Very few of the current devices I don't think any of them really adapt to the mitral valve, and most of them are circular, and they're not even D-shaped, which is at least close to the anatomy that you showed there. I think we'll all know a big reason why a lot of these have not taken off is because of screen failures, and that's primarily anatomic. While a lot of that is LVOT obstruction, I think PVL and the concern about calcium is a huge part of that. And so in that sense, I do think this is a unique view on the space, and it's worth seriously considering.
Great.
Thanks, sure. I think that was a great presentation. I think initially you started out with just a ring concept, right? And now you're doing a full valve.
Right, but important to say that we did get a clear indication and validation of using the balloons and the frame as a docking system for surgical valves in a minimally invasive manner.
No, I think that was a very smart move that lets you create and control your own destiny, right? I think there are some obvious technical questions, right, around stability, durability, and you'll go through that, and most of them are probably surmountable. I think as an investor, my major concern would be timing, right? You may be too early and you may be too late at the same time, right? Because by the time you're going into your pivotal, you may have a few companies on the market with a commercial device or running other pivotal trials, so you'll be enrolling against not just the tier technologies, right? So against other TMVR technologies, and some of them are also now claiming that they can address the PVL issue and the LVOT issue. So I think enrollment in a trial like that would be a slug and a little bit scary from an investor's perspective. But I think it's an elegant technology. It's very unique. So I'd still be rooting for you, but as an investor, I think it's tough. The space is tough.
Great. I'm going to cut you off just because we have to make up time. Sorry, Jonathan. Frederick, good job. Shira, excellent.
Thank you. May I comment on Frederick?
Yes, ma'am, you can.
Thank you. Okay, so a few important things. As for getting patients enrolled into the trials, I can say that we already have, only presenting one time the company, we already have three hospitals in the US and also in Europe that are interested in doing the first in human. And I forgot everything else, so never mind.
One question, Fred. Would you be more excited if this was a tricuspid application?
Potentially, although there's a lot of acceleration happening there as well, so tough to say where they will be in 3 to 4 years, right?
I still like the vet area. They get reimbursed because they pay out of pocket for their poodles, and there's no FDA.
All right, can we grab the IRS up, please?
Dogs in Durham today. Okay, very nice.
Thank you, sure.
More adaptable mitral and tricuspid designs, and the judges were very impressed with the design, very impressed with the simplicity, and actually also hoping that you can focus your efforts ideally on the tricuspid side of things where there is a real need. So congratulations, thank you for coming all the way here, and if you say a few words.
Sure.
Yep.
Say a few words.
Yeah,
Please.
so thank you. An amazing honor. Thank you for the dogs. Thank you. I'm so appreciative of my journey, starting from dogs and going up to humans, and maybe in the future going back to dogs and also saving them. And I hope it's not our last word. We'll be in the future presenting some more data, and this amazing award allows us to continue our work. So thank you so much.
So the TCT trophy here is good, but what really matters is what's coming next, okay? $200,000 check. Don't try to cash this. You will be getting a check in the mail, so. Courtesy of John DeHaan, the John DeHaan Foundation. Good. Thanks again, everybody. A terrific attendance this morning. We hope you enjoyed it as much as we did.